Imagine you had to make a decision, say, whether or not to buy flight delay insurance. You'd probably start by asking yourself a series of questions. What season is it? Where am I flying? What's the weather like? How likely is a delay? Depending on your answers, you'd reach a conclusion. This is exactly how a decision tree algorithm works. A decision tree is a machine learning method that mimics the way we make decisions in real life, by asking the right questions in a logical order. It's used for both classification problems, where the outcome is a category like yes or no, and regression problems, where the outcome is a number, like predicting sales. At its core, the decision tree works by splitting data into smaller and smaller groups based on features, characteristics of the data, until it's easy to make a prediction. Think of it as a tree where every split in the branch is a question, and each path down the tree leads to a final answer, a prediction. For example, let's return to the flight insurance question. Suppose we start with the feature, season. If it's winter, that could increase the risk of delays. From there, we check destination. Maybe flights to Chicago are more prone to issues. Then we ask about weather. If there's a storm, the likelihood of a delay is higher. Each of these questions branches the tree further. Eventually, you reach a point where the answer is clear: yes, buy the insurance. But how does the algorithm choose which question to ask first? That's where mathematical criteria come in. It evaluates how well each feature splits the data, how much it reduces uncertainty or impurity. Common techniques include the Gini index, entropy, and information gain. The goal is to find the best possible question at each step to move closer to a confident prediction. You can also control how complex the tree becomes. For instance, you might set a maximum depth, how many questions deep it can go, or a minimum number of data points required to make a split. This prevents the model from overfitting, that is, learning the training data too perfectly but failing to generalize to new data. One of the best parts about decision trees is how easy they are to interpret. You can literally follow the flow of questions down a tree diagram to understand why a prediction was made. This transparency is a major advantage in areas like healthcare or finance, where understanding the why behind a decision is just as important as the outcome. However, decision trees are not perfect. They can become unstable. Small changes in the data might lead to a very different tree. They also tend to overfit, especially when left to grow deep and complex. That's why advanced versions like random forests and gradient-boosted trees were created. These combine multiple decision trees to improve accuracy and robustness. Decision trees are widely used in many industries. Doctors use them to support medical diagnoses. Banks apply them to determine whether to approve a loan. Marketers predict whether a customer will churn. And yes, you could even use one to decide whether to buy flight delay insurance. In short, decision trees help machines make decisions just like humans do, by asking good questions, one step at a time.